Hey, everybody. Welcome back to the podcast after a long hiatus. I'm excited to start a bit of a new series when I'm talking to a lot more people who are building open models. I think historically, I've obviously talked to people I work with, but there's a lot of news that has happened in 2025. And I'm excited to be with one of the teams, a mix of product, which is Richard Bian, and some technical members from the Ant Ling team as well, which is like Chen Liang and Ziqi Liu. Come back in a year and my Chinese pronunciation will be better. But really, this is going to be a podcast where we talk about how you're all building models, why you do this. We'll talk about different perspectives between US, China, and a lot of us going towards a similar goal. I was connected first with Richard, who's also talked to other people that help with interconnects. And we can start there and go through and just kind of talk about what you do, and we'll roll through the story of building models and why we do this.
Yeah. Hi. Again, thanks so much, Nathan. Thanks so much for having us. My name is Richard Bian. I'm currently leading the product and growth team of Ant Ling, which is part of Inclusion AI Lab of Ant Group. So Ant Group is a master company Alipay, which might be a product which many more people knows about. But the group has been there for quite some time, and it used to be affiliate of Alibaba, but now it's a separate company since 2020. I am actually having a pretty mixed background. Before I joined the Ling team, I've been doing an open source for 4 years. In fact, I built an open source from technical strategy, which is basically one-liner from our current CTO, all the way into a full-fledged multifunctional team of 8 people. In 4 years. So it has been a pretty rewarding journey. And before that, my last life, like I've been spending 11 years in the States working as a software engineer with Microsoft and with Square. Again, it was a pretty rewarding past. I returned back to China during COVID to be close with my family. It was a conscious decision. So far so good. It has been a pretty rewarding journey. And I really love how, Nathan, you name your column as interconnect, and you actually echoed when you just began the conversation just now. I found that to be a very noble initiative. So very honored to be here.
Yeah, hopefully first of many. But I think you all have been doing very interesting stuff in the last few weeks, so it's definitely last few months, so it's very warranted. Do you two want to introduce yourselves as well?
Me first. My name is Chen Liang, and I'm the algorithm engineer of LinkedIn, and I'm mainly responsible for the float pointing 8.8 training during the pre-train. Thank you.
Okay, my name is Ziqi Liu, and I'm graduate from as a PhD from Jiao Tong University in China, and I've been working at Ant Group for about 8 years, and currently I'm working on the Ling language model. Yeah, that's it.
Nice. I think the way this will flow is I'm going to probably transition. It'll start more with Richard, which is like direction. And then as we go, it'll get more technical. Please jump in. I think that we don't want to kind of segment this. I mean, the border between product growth, technical modeling, whatever that's like why AI is fun, is because it's small.
Mm-hmm.
But like, I would like to know how Inclusion AI started and all these initiatives. I don't know if there's a link to Ant OSS. I found that in prep and I thought that was pretty interesting. And just kind of like, how does the birth of a new language modeling lab go from idea to releasing 1 trillion parameter models? So like, what does that feel like on the ground?
There's actually one additional suffix for that in 8 months' time. In fact, we kind of began all of this initiative in February this year. So like just to begin with, for the audience who probably doesn't know much about Inclusion AI, Inclusion AI basically envisions AGI as a humanity's shared milestone, not a privileged asset. So we started this initiative back in the February of 2025. inspired by the DeepSeek Research Lab. Yeah, so the DeepSeek Research Lab and their publication, in fact, motivated a lot of people. I believe not only in China, but globally, on taking one step more closer to the AGI initiative by showing it's probably not an exclusive game for only the richest people who can afford the best hardware and the best talent. Yeah, so the way we kind of look at it is like why we name that inclusion is because we actually have that gene, with the company. Yeah, so like the decision was actually made, of course, the decision was made beyond my pay grade, but it was actually very well informed internally for the mission and vision that we want to be more like DeepSeek, which is a research lab with a dedicated effort of pursuing AGI. In fact, I mean, if you kind of like think about Ant Group with our business model, like we're a fintech company, to some extent very similar to a combination of Square, Stripe, and many other companies in the States. We have like a very broad range of, like businesses, which focus not only on the financial vertical, but on medical, insurances, and technical services as well. Yeah, so a lot of those businesses. In order for us to actually be able to support those businesses in, I would say, long-term success in the next 5 to 10 years is going to be critically important for us to be able to really focus on the fundamentals of AI. And we feel that, the language model is a key to that door. If we kind of give up on that, yeah.
There's a lot here, and I agree with this, and I think that it's like the Ant Group is a big, large tech company, and I think large tech companies being able to train AI as like most of the audience here is going to be like, yes, they definitely should be doing this. It's a transformative technology. I think the two things to double click on are we're going to have to define like what you think of as AGI and why you're pursuing this, because it has to go deeper than like a term that we are doing. I know like DeepSeek is very ideological in their pursuit of intelligence. So I think it's good to do that. And then I'll also double click on the question of like why open models and like because DeepSeek is doing like open and as strong as they can. They're text only. We'll talk about this later. But it's like let's do each of these individually to kind of ground the motivation.
Sure. I guess, I mean, for AGI, the way kind of we're looking at it is like, I don't think there's a definitive answer to that. I mean, like if we kind of search Google or any other search engines, it will give you a line, which means something, but it doesn't mean anything, honestly, to me personally, just by looking at the definition. I will probably use a metaphor. People are probably very familiar with the navigation era, right? The glorious navigation era back in the 14th. Now, I think it feels more like all the ships are just leaving Lisbon last year.
I love it. I agree with more like than this than most of the definitions.
Right.
Because like, a lot of the definitions are grounded in like work or something.
Yeah. So,
it's like
the way I'm kind of looking at it is like, all the ships are leaving Lisbon. Some of them are heading west, knowing for a fact that, hey, India is over there. But, like now we all know the truth that India is on the east side, but it doesn't matter, right? It found the whole American continent. The way I'm kind of looking into the definition of AGI right now is like, I personally have a very firm belief that, human intelligence and machine intelligence, to some extent, are having their similarities. And, humans are trying to some extent, explore the limit of the human intelligence with the help from the machines. So when everything was beginning, we're kind of using all of this as a copilot mode. But moving forward, there are all of these theories indicating that, there might be an intrinsic point that, the machine intelligence, it goes all the way back from the Turing time. They believe that machine intelligence might at one point exceeding the human intelligence. So I guess we're looking into that pivoting point. Before we reach there, honestly, I don't know, where we're going and how long we can go towards that particular direction. But clearly, there are some common consensus right now, right? Including maybe MOE as a, architecture, including that, the pre-training. Even to some extent, we're seeing, a diminishing return, but pre-training is still pretty important. And, reinforcement learning to some extent is probably another general agreement that, this might not be wrong. We don't know if this is right, but it might not be wrong. So there are all of this kind of like exploratory directions that we believe in. So we're just kind of sailing there and see how that goes. Yeah.
I love this. And I think the crucial question is asked like Chen or Ziqi is like, is the team, like, how do you build team alignment around this? Is this something that you feel like you walk into the office or get on a call and everybody's in agreement? Or is this like a vision that you're still like building or trying to sell? Like, to what extent you could say? Because I think there's a big difference between like, I buy the vision for inclusion AI, but it's like, how real is this when you're across the org?
Yeah, I can maybe share my feeling, and Ziqi and Chen can chime in. Of course, at the very beginning, there's suspicion. It's by human nature, right? So the way we're looking at it is like, I think DeepSeek actually gives a very clear indication that, hey, this might be working. There has been this hazy, chaotic era of 2024, which nobody has, the tools to navigate. So like, people are very cautious about sailing. You see ships going out and came back, crippled, and you begin worry about, hey, what's going on there?
I think
now,
there's a big difference between the U.S. because I think in the U.S. everybody was bought in, and I've talked to a few more labs in China, and it like there's so much emotional energy on the DeepSeek moment in China that I think in the US people forget about it, where it's like I could see this in the sequence of releases as well, because it's like everybody a few months after DeepSeek, like all these labs start in China have started releasing models. And I just think that it's good to have you say this and to share this with people so people can internalize like how much has been mobilized and this kind of culturally salient point.
Yeah, it's motivating. To some extent, there was this very, famous navigator called Zheng He, right? Back in the Ming Dynasty. So I think like basically when Zheng He was able to kind of pretty much pull through the trip all the way to India from China, people begin realizing that, hey, not only the Portuguese can do this kind of like long journey sailings, right? The Chinese can do that too. And we're exploring the different part of the map. Toward the end of the day, like nobody knows the whole picture. So the way I'm kind of looking at it is like, first, I'm very, brought into the mission, to the extent that it kind of feels like, even though we begin sailing late, but we do have our own kind of taste to this game. So we will be able to contribute. And you did ask about the question, like why we chose to be open, right? To some extent, I kind of really believe that open is a choice. Just like how, the leaders in this game are not the most open player in the game, right? But if you kind of think about playing poker, right, the chip leader has their own strategy, which is all understandable. But, as for us, because we joined the game at this stage, I guess the best strategy we kind of feel is like, really trying to follow suit to the right direction to minimize, the mistakes we're making at this moment because we sail late. The second, stay open and stay polished, right? So like keep a very open mind about what's going on in the surroundings. And that's probably the best we can do. Yeah, that's my 2 cents.
Yeah, to provide some color, and I have like a whole note in the page that I will release with this for people listening. The first Ling model, which is like their text-only model, very you could see inspirations from DeepSeek in the architecture, was in April, and then a big updated Ling 1.5 in July, and then in September or recently was Ling 2.0, which also came with a multimodal Ming and a reasoning ring models. And I think like by this September release is when like me and the couple people that work at Interconnects were like, holy crap, like this is like very much a real deal model. And to kind of ramp in that period of time is not easy. Like there's a lot of companies in the US that are trying to do this right now. A few companies in China have shown that they can do this. And it's like, I guess if you want to explain this kind of Ling, Ring, Ming series of models and like if this is a clear strategy behind this or if this what works, like how did you evolve through the first models through the summer to today to kind of get to this point?
Yeah, sure. So I mean, first thing first, I think the foundation model is really important. To some extent, like I've been working with many people on the system side because Ant Group has a very solid cloud native infrastructure team. So the team has been, like when we talk about this, we kind of begin using the metaphor, like the model is really like the operating system, but it's not like the operating system itself, but it's more like the kernel, right? So only a few people can actually write kernel code, even nowadays. Just like how there's only a few most talented people who can actually work on the model team right now. We feel that it's not only a key leading to the technical future, but it's also a key of leading to the user experience future, because we do see the I personally believe in the trend of technology brings in new interactions, which will lead to new product, which will lead to new business models, which will lead to potentially new organization structure, rinse and repeat. So we kind of like really choose to do the fundamental model of the Ling series because of that. And the Ring series is obvious next, given the relationship between V3 and R1. It definitely indicates about, how we can potentially take a very polished, actually a very intelligent individual and polished and put some reinforcement learning on it to make it a much better individual in one clear vertical direction. We're going to be touching on some of those kind of technical aspects in our conversation next. But that has been a very clear direction.
Do you see this evolving with kind of feedback from within Ant Group, which is like you've also released this diffusion language model, which is a diffusion language models are very interesting. I'm gonna just go on a little bit of a side rant because I was talking to people about these, and it's like very hit or miss with me whether or not I think they're going to be big, because we see that tool use and reasoning is a big thing. So the whole idea of a diffusion language model is you generate a very long sequence at once, and that could save on costs because you don't have this kind of quadratic memory increase and you do very long sequences. So I saw that and I was optimistic. And then you see the idea of tool use, which is like you have to be able to chop up the reasoning. And I was like, oh, I'm really bearish on diffusion models for language again, because you have to be able to search and execute code. But then I was hearing that in like user-facing products like code diffs, where if you're generating a website and you did take a prompt and go to a huge diff on a code base really fast, then language diffusion is actually really nice. And the motivation of the question is like, do you have this feedback loop in your modeling where Ant Group is trying to use these for things for products and might like have a bit of a feedback of like this latency isn't fast enough, or like this area you need to move it to? Or is this kind of like a separate play of just build the best models you can and figure it out later?
That's a very perfect question. We use this metaphor that we're probably also doing this reinforcement learning in real life by trial and error. Right, almost kind of feels like. So I think Nathan, you nail a very good question, and there are some very clear consensus about coding agents to use, and people are kind of going down that path and pursuing their own business models and begin making revenues. So that's one type of usage patterns for language models. We do that, and we see some very clear, I would say, feedback loops in that direction. So that's one pillar. And the second pillar is about, the not so short aspect. I think the not so short aspect is like, I believe everyone in the Silicon Valley and in Seattle are still scratching their heads, trying to understand about, hey, when can we break even with all this investment, right? Are we really generating enough user values? Kind of back to, I'm a product person. So all of those kind of words keep coming back into my head. And, at this moment, consciously speaking, it's very hard to come to the conclusion that, all of this is valuable enough for the end user. But, we're trying to explore the directions for that. I would say a lot of the, generating the whole website, what Labo did, right, was like, it's an interesting form of product. But, at this moment, we don't know if it's A, sustainable as a business model, B, if this is the best type of product we can offer to the user. So all of those are iterative. Within company, we do have some of those explorative products that, uses our models, not only the Ring model, but Ming as well, like the multi-model. And you mentioned about So that's the second pillar. And the LADA is more like the last pillar, because Ant Group does have a research institution called Ant Research. So the LADA model is a joint collaboration between Ant Research and the Ling team.
Yeah,
So
I guess there's another like
yeah.
org chart question, which is like, where in the structure of the big tech company that is Ant did this inclusion AI / Ling and all of this grow? Like, is this within cloud that there's a new modeling or research org, or is it kind of separate? Like, do you feel like this is a part of the bigger company, or are you kind of insulated from this?
You can actually, search on Google and find information about Ant Research, which is a joint research lab focusing more on a lot of these frontier technologies like graph, deep learning, reinforcement learning, before all of this. So that's a background of Ant Research. And second, when we begin forming the AGI initiative of inclusion AI, we begin getting very serious. So we kind of begin putting all of these resources together, to some extent physically, but more from the, the organizational ways of saying that, hey, all of these teams of foundation models and research lab institution, and then, the user experience expert focusing on exploratively looking into the next big, application that people will actually use. So all of this, we kind of begin forming this internal, I wouldn't call that organization, but more like this kind of this internal initiative, directly driven by our CTO. So it's very serious effort. It's very serious to the extent that, feels more like when, the team actually formed the original DeepSeek initiative. So all of these people, you do nothing else but only focusing on this. And this is the only important thing for this.
It's like so much of this is that the mystique, I feel like, is that in the West, we don't get what would normally be gossip of what is happening in the Chinese tech ecosystem. Which, like, I don't think this is like hard to see if you have friends that work at Ant Group, because it's probably you're moving hundreds of people's jobs around and people talk. Whereas like in my circles, it's like, oh, Meta's doing another reorg, and then you hear about it in the news a few days later. So it's like it's just like, I don't know. That's my reflection hearing all of this, and I'm mostly learning that all of these orgs end up similar in size, and then you have to prioritize resources per researcher and all of these normal things. I'm gonna start transitioning into this section we had prepped on actual modeling things, which is mostly on pre-training, which is fun. I think that state of affairs on my pre-training knowledge from AI2 is that we've done plenty of dense models and some architecture things from up to like 32B, some experiments at 70B. That one didn't work out. MOE is work in progress. So I'm personally very interested in architectural decisions that enable MOEs and long context. I think the kind of basic thing is just like, if you're pre-training, I mean, this is for Ziqi, is like, how do you feel like your trajectory is as a researcher as you're going through these months? This could be just like, what does your work feel like when you're trying to boot up like a DeepSeek style, very ambitious lab, building new infrastructure and getting models off the ground? And then we'll kind of go into some more specific discussions around like Ling 1T later and stuff like this. But it's like, how is building this?
Actually, our texture, we indeed refer to OpenAI's scaling law or DeepSeek scaling law. They really do a good job. In our Ling scaling law, basically the non-embedding training flows play the central role of our scaling law. So we set up our own framework that provides foundation for a standardized experimental pipeline. So there are many questions when we start conducting scaling law under the MOE architecture. So the first question is, can we find simple rules for finding optimal hyperparameters with respect to training flows, which are not sensitive to the structure of MOE? Similar to DeepSeek, we first discovered the optimal critical hyperparameters with respect to training flows and the MOE architecture. We find those optimal hyperparameters are not that sensitive to the structure of MOE, like the activation ratio and something others in a mild condition, but more related to the training flows. So this is our first funding. And then we found activation ratio is critical and can consistently improve if we reduce the activation ratio.
I mean, most of pre-training is a lot of different things, which you're accumulating flop efficiency while getting model performance. And then it's like, Chen, you also were saying you focused on FP8 stability, FP8 and training stability in general. So I'm kind of curious of like any major, like, what is your biggest impressions of focusing on kind of this narrow thing at pre-training, which is getting more memory by using lower precision and while maintaining stability. So if you have any like high level takes on pre-training stability at that precision, then I'll zoom into more specific questions on scaling up from there.
At first, we heard about the flow point 8 from DeepSeek. They use 1.8 training through the pre-training of DeepSeek. And then we also try the recipe of them, the blockwise in the Megatron. And we find that actually the MFU is not very high, and sometimes it's even slower than the bfloat 16 training. And we find that the mainly course is on the quantization and dequantization. So actually the float 0.8 is not fast as they claimed actually. And we profile the whole training data and try to minimize the quantization and dequantization process.
What is getting quantized and dequantized?
Yeah, if you want to try to the flow 0.8 training, it's actually do the GMM in the linear, right? And you want to quantize the weight and the input to E4M3 type, but the other structure they compute in the BF16, bflow 16 type, right? If you so when you get into the linear, you need to quantize it to the float 0.8 and then do the GMM, and the GMM output is the bfloat 16. So this is the way you need to quantize and dequantize to adapt the other structure.
And then what does your work actually look like in getting this? So you find it to be not as fast. Like, what do you actually do to change this?
In the MOE layer, it's got the FC1 and FC2, right? And then in the middle of them, they got the switch gated function. So FCE switch gated function and FC2. And the output of FC1 is the bflow 16. And we fuse the operation of the switch gated function and the quantization function. So we fuse them, the two operations, into one, and so it saves some times. And join the MOE there is a batch operation. So you need to do the activation function on all the experts, right? So that's a lot of time.
Yeah. And for people listening, FC is fully connected, which is just the standard neural networks. Okay, so I might be being silly, but generally the idea with MOEs is that you have the feed forward layers take up the most parameters, and you get more efficient by adding MOEs. And within the MOE, kind of gated to each expert, is it actually standard that it's like fully connected MOE gate, fully connected, and it's kind of alternating? Because I know this normally like attention block, MOE block is like the higher level of abstraction. And is this fully connected MOE gating and then fully connected like actually industry standard? And I just had like a lapse in my brain.
And this structure is convention actually. And some experiments has explained that the switch gated can make your gradient stable during the training. So it's actually a standard architecture.
When you're actually experimenting on this, is this the sort of thing that when you're doing it at your like first models were about 300B total and you had smaller models, like is this a sort of one and done where you get this performance at every scale, or do you have to revisit this when you're doing something like Ling 1T, which is this latest model with way more parameters? Because I think that the root of my question is like, are the numerical problems you get from scaling like whack-a-mole, where it's like an old problem that you fixed becomes a problem again, or is it an entirely new type of thing that comes up when you're going to big models?
We do the experiment on the like the size of 100 billion parameters first, and also the situation can be we can learn from the situation at that size, not just the 1T.
Yeah, and I remember reading, I saw that you guys did QK norm
Yeah.
for this as well. Is this just like you also found this to be standard and work for you? Because we've had some issues with log context and doing QK norm kind of hurting performance there. We still have some ablations to track down.
Yeah, we actually do the experiment of the QK norm on bfloat 16, and the result comes out the loss is better than you didn't apply the QK norm. And actually, the one big thing is that when you do the flow point A training, if you do not apply QK norm before the rotary embedding, the gradient of the linear QKV may be underflow. Most of the time it's underflow because of the without the QK norm. So if we want to apply the flow point A training, you need to add the QK norm, and to avoid the quantization error. Since the quantization error is propagate from the last layer to the first, right? And if the last layer got more quantization error, and until the first layer is the amplified error.
Okay, let me try to talk through this because I'm mostly working post training and I've heard all these terms and I want to make sure that we're presenting a fairly clear picture to people. So in intention, we have queries, keys, and values, and these are big matrices that store many different things. And like generally with pre-training, the magnitude of the variables matters a lot because what you're saying about like gradient flow, and if you have variables that are like too small, you might have no signal, and too big or one thing. And what we're saying is that God, I guess what's the order between when you have, I guess there's complicated things, which is like where the rotary embeddings are applied relative to the attention computation. And what we're saying is that you have to put QK norm ahead of the rotary embeddings in this attention module, because then otherwise your like gradients are too small when you're scaling this,
Yeah.
or with FBA.
Yeah. During the forward process, you got the QK norm and the rotary embedding, and then you go forward, right? But during the backward, but during it's if you do not apply QK norm, the Q times K matrix may be got large values, right? And during the backward, the large value may bring a large gradient, and when you do the quantization, you actually the data divide by the max of the like the per channel the max of the column. So some small values will be divided nearly to the zero. So when you do the dequantize, it cannot find the real value of the before the quantization.
That makes sense. I see. And like, what are you actually looking at to figure this out? Are you looking at like intermediate activation values when you're scaling? Because I like training loss will only show you so much. Or are you like seeing that the training loss is better or worse and then going to investigate this later?
Yeah, the first signal is the loss is not right with compared to the bfloat 16, and we print the quantization error during the intermediate layers, and find that without QKNOM in the linear QKV, the gradient is too large.
Yeah, I think that this is very good. It gives people a sense for like what the different things moving around when you're looking at kind of pre-training research is. And then the other side of things, if you make a change and then you have a loss spike, you're like, okay, then you have like a numerical stability issue. I guess like a loss spike that you can't skip. So I'm guessing you have things where if you have a loss spike, you can skip some of them, and like, but there's some numerical stability you can't get around. This is fun. I'm going to kind of keep rolling through this. I think that you're also talking about how you have like different pipeline for training your MOE, which you described as like a heterogeneous, fine-grained pipeline. I think that this is like a I would read this as matching your training architecture to your compute architecture in order to get a speed up. Because I think with like MOEs and the communication bottleneck. So I think that it's like, if you want to talk about the parallelism strategies you did to get pre-training to be efficient, I think it was also really interesting because it covers multiple layers of the stack and how you design models.
Yeah, it's actually a common way, not just for our model. So actually, the modern parallelism is just data parallel, tensor parallel, pipeline parallel, and context parallel. Right? And our optimization is only focused on the pipeline parallel. As you can see from the paper, we do not use TP during our pre-train. Yeah, so the common way to do the pre-training is they name the one forward and one backward type. So let's see, we got we just focus on the one machine with 8 cards, and every card actually we named it's a stage. So we got stage 0 to stage 7, right? And every stage do the forward and the backward after do the forward and send the forward data to the next stage, and they get the backward data from the next stage, right? It's
so that's like an 8-step pipeline. That's like a pipeline parallel that you're describing,
yeah,
which is like,
and the every stage, like they do communication from the prior stage and do the communication with the next stage. The one forward and one B got a problem that the stage 0 and stage 7 always got the most computation load, because the stage 1 you have a embedding layer and it's a index select operation, so it's closed. And stage 7 you got the MTP layer and the loss function, and you also got a large GMM. So you need to time the hidden states with the vocab to transfer the hidden states to the vocab size, and the vocab size always large, right? So
how much fine-grained work are you doing to change like which part of the model is on each stage? Because that seems like what it would be then is you have, or you either have to change the model or you have to change how you split up the model. It's like your two options, right?
The common way is just you slip the MTP layer and embedding layer and just divide it by the GPU number. So it's natural that the stage 0 and the stage 7 got much more computation load, since you just ignore the balance of the system when you split the layers. So it's the common way. Yeah. So our optimization is the main concern is just to alleviate the computation load of the stage 0 and stage 7.
I see. I guess if you could say more about what that actually, I guess I don't fully follow like what has happened. I'm trying to be like very clear of whether or not I understand it, because I think that's like, in a dense model, I think pipeline parallels really, really make sense. But you have like a smaller model, and then as you're like getting bigger, it's like much less of a model, and I don't know what it means to necessarily like deload the specifically the embeddings or the loss function and how much of a change you can make. But I think that might be like a me limitation. It might be hard to get to, but I'm curious if you want to try.
Actually, it's not quite it's quite same as the dance model. The only difference is that the every GPU you can imagine that our during the pre-train, it's got if we got the 32 expert and we use like 4 cards to a 4 machine to gather the expert data. So it's just you can view this 4 machine as one machine. So it's in this view, it's the same like the dense model, right? So just imagine the dense model. You split the layers according to your GPU cards, right? And let us assume that every machine got two layers of the dense model. So
yeah. So I get that, and then it's just like then you have to shift things around to make it so the loss is less of a bottleneck in the last layer, or the final part of this pipeline parallel being the bottleneck is kind of potentially fundamental. That's like I see.
yeah.
I mean, the next question that I wanted to ask is going to be very related to this, which is like, how do you? It's like, what is your neck? How do you scale this to make RL work at the same scale? So the difference is the different problems that you have for doing pre-training versus RL with a
Yeah.
large scale model. I don't have the title of the paper, but you're like in this Ling 1 tree paper, there's a ton of RL details. And it's like, is this kind of just like the next sequential problem that you got to? And then there's just a lot of not necessarily similar solutions, but like you're problem solving in the same way to make RL work rather than pre-training in terms of throughput.
Yeah, it's actually got some common tricks like we mentioned in the paper the VPP, the virtual pipeline paradigm. So it's actually means that the machine you got double layers than the original one, and then the original one if one forward one back things and but the difference is let us assume that the stage 0 machine got 4 layers, but actually during the time, 2 layers is due to computing and 2 layers is due to communication. So that's what they call VPP.
What does 2 layers computing and communicating mean?
It's in other words, some layers is doing computing and the some layer is just prepare the data. They get the data.
I see. So like some machines.
Yeah. So when the machine do the computing, the communication bandwidth is idle, right? So they utilize this to like just like the exploration as exploration. And we our optimization is just to split the pipeline more precisely.
Okay, so I think I'm seeing this. So it's within a node, you have very fast communication between 8 GPUs. And then in pre-training, you're kind of doing all sequentially. But in RL, you need to kind of sync this. You need to communicate more between your like generate. You have to move your weights to be able to generate when you're doing RL. There's like this sync step. And then I'm thinking what you're saying is like you have this chunk on 8 GPUs, and then you can split this so half of them are doing compute and half are doing communication at the same time, so kind of like alleviate the bottlenecks.
Yeah. And
I
just
see. So like for context and how like there's a lot of different ways of doing RL infrastructure. It's just the abstractions that like what we're doing is much easier, where we're looking at approaches where we have GPUs that are set for generation and training, and that we are primarily looking at ways to make those both faster and then be able to throw the like training GPUs. We sync the weights to the generators and the generators just keep going. Where this is like it's much more deeply embedded in the architecture where you have like one cluster where you're kind of splitting the GPUs and what work is happening across each of the across like the per node basis when you're doing this RL training. And I'm going to go look at this in more detail. I think
So like just to add a little bit more flavors to this, the reason why we kind of like didn't really cover a lot of post-training details in this interview is because we have some additional technical papers or technical reports we're writing at this moment about the system.
That makes sense.
So it was to some extent intentionally vague, Nathan. But I mean, first thing first, the current paper of Ling 1T and Ring 1T does have the fundamental intro for our system. It's called like a system. I believe the article has been published on Ant Ling medium.com on the Medium technical paper, as well as on LinkedIn for so the paper is also available in English on link in as we publish all the details. So specifically, there are several things in which we did for the RL aspect. One is about the system itself. You can imagine that we do have a optimized internal hybrid engine, which does all the things you described. And the second part is like we're exploring the reward model system. So this reward model system essentially requires some additional design to reach a certain level of parallelism. And the way we're kind of looking into that is like we're really trying to set up like meaningful rewards by doing like a parallel structure for that. Last but not least, like we have the term called LPO, right? The linguistic unit. So we decide to choose sentence intentionally. So it's kind of like a different approach from GRPO and the GSPO, like the sessional approaches or the token approaches, that some of the other labs are using. We intentionally chose like language as a linguistic unit to explore the meaning of this. Yeah, so far, like we've
I've been wanting
seeing
somebody to do this.
very motivating results from doing that. The training stability and the generalism is actually, we see some pretty clear numbers indicating that the LPO can be a very viable option for the IR training. Yeah, so let's maybe save some of those interesting dessert for our next conversation, and we would love to really being able to share a lot of those details given your background in post training. I will try to maybe invite some of the experts from that domain into our next conversation.
Yes, I think the LPO thing is interesting. Yeah, that there's kind of a natural abstraction in a sentence. So when the language model generates, you just split every generation per sentence or per punctuation mark. It's very linked to kind of these ideas of process reward models that people have looked at and understand to have natural inductive biases for a long time. And there is still some research doing this, so I'm happy to see that you're doing it. And it's kind of, I think of it as like value models and other things in RL that are just out of vogue and are likely to come back in some form in the near future, which is cool. Ecosystem, where you see open models going, I think it's like, I guess the high level question is like, I mean, this weighs heavily on myself personally. It's like, do you think that it's like a big cake that you can eat out of and that everybody does? Like, is it like you see a clear path to having models that are meaningful? Does it worry you that like to list a handful in China, it's like, I mean, we know DeepSeek, we know Quen, we know Kimi Moonshot, we know GLM 4.5. Meituan is releasing good, very strong models right now. You guys are like, the conviction that this is like a winning thing and you have your niche and there are more models coming soon. Like, is that easy for you to see? I mean, you had your metaphors at the beginning that I thought were great. So I think that's kind of partially answered, but it's like, it's a very competitive space. So is that like easy for you to see through and just keep pushing ahead?
Sure. Well, I mean, again, thanks so much, Nathan, for really having this conversation. I did actually having my lines at the very beginning. I kind of call myself as a global citizen. So, some of the current, I would say, tension really pains me in that regard. So what I'm kind of looking at is like, so first thing first, I've been doing open source for years. You did ask about, like AntOSS. You can actually find AntOSS on Twitter. And there's also a website for that. It's opensource.antgroup.com. So Ant Group actually has a very long history of doing, as we call nowadays, like the traditional or the classic open source, quote unquote, right? like, which I believe will be there forever. And you did ask a very specific question about like open source models or open models. Last year, this time, it has been a very heated conversation in the open source ecosystem, right? So people in the open source domain are saying that, hey, this is, OpenWeights is not open source at all, which makes perfect sense, right? Because if you kind of think about the nature of open source, it has at least three entities which are critically important. One is the code itself, and the other one is community, aka the developers and people around it, and the last one is the license. which pretty much provide a common consensus, or the, I would say the most common denominator as people agrees upon, which is legally viable too. But coming to that license requires like years of effort. So like last year, you do see the OSI is trying to come out with a definition, and people are having very convoluted feeling about it. And then we see the Linux Foundation and data release this model openness framework, which is a very viable way of measuring the models. But that said, even nowadays, we only see one class one, which is a model from BAI in China, which meets that standard. The rest of the models doesn't meet it. And funny enough, last year, like when you say, hey, we're open sourcing our models, you'll see people kind of begin pointing fingers that, hey, you're not open sourcing our models. Be careful about their words. But this year, all the labs are saying we're open sourcing our models, and nobody's pointing fingers at all. Because it's just like getting too, it kind of gets to a situation that we should maybe care less about this, but more about, the direction or, what's next. So I definitely want to spend more time discussing about that. So first thing first, I would say, I did use the metaphor of saying the LLM is more like kernels. Right? So if we kind of think about how many Linux kernel developers on the planet now, it's probably less than 1,000 people. So when people are saying that, hey, LLM is not really open source because nobody can contribute to it. Yes, that's correct. It's very similar to the kernel. Vertically, you can contribute to the kernel, but in reality, there's only so few people knows about it. Most of the people are really kind of working around the ecosystem. They're not the kernel developers, but we are currently at the stage of building the kernel itself. So that's basically maybe my first point. It takes time. The reason why the open source definition is so convoluted at this moment, maybe just because it's first or the second year of the new era of technology development.
I'd say it'll take like a decade. It's like we're in the first couple years.
Yeah.
I reiterate strongly with what you say, where it's like it's much better that people are actually using these models than just getting annoyed about definitions. And it's like we'll figure out the definitions much more quickly if people actually want to use and contribute to these things.
Yeah. And then the next slide coming after this is like, I'm just sharing a very interesting story because my previous leader, he was working on Kubernetes and containers. So I am having a background of being a full stack engineer as well as an engineer working on the data infra and data platform. So one day we did have a conversation about, I was like saying, hey, this MySQL infra. He was like, stop. MySQL is not the infra. MySQL is application. I was like, okay, thank you. That's very helpful. It's kind of interesting, right? Because if you, if you think about, why that particular conversation actually happened, it's because if you're perceiving this from, the infrastructure perspective, or if you're perceiving this from application perspective, my hunch feeling is, we are going towards the next stage as we speak right now. I think we're at the transition period of having this MySQL moment. So like, other agentic sandbox, agentic runtime, at this moment, that seems to be more application related. But 5 years down the road, they'll become infrastructure. So the way I'm kind of looking at it is like, first thing first, I'm very optimistic about that, we will have an open source. We will have an ecosystem in the Gen AI era. In fact, I think Matt White from PyTorch, I think he introduced this new license called OpenMDW license, which kind of begins treating
underrated license. Like it's like very, very reasonable license.
Yeah, it's very reasonable. In fact, we're writing some Chinese articles trying to. I'm working with our legals to do that. It deserves better visibility and more promotion. Kind of back to our original topic, I guess is again it will take quite some time for this information to rinse and repeat and consolidate. But I guess at this moment I do see 3 gaps which will prevent us from going to the next step. One is a proper license structure and a proper governance around the license. I think the OpenMDW is a good start, but it will take time. Second, I do believe in like data is a new code. I guess like how you're contributing to the LLM is really kind of through the data of pre-training and, like your data and rewards models in post-training. But at this moment, there's no gate for data. And the gate for data is not as straightforward as the gate for code, because, data can really be something which is very fundamental. So for instance, I mean, like,
it's often impermanent too. So like a lot of multimodal data sets are released as links and then the links die. So it's like,
right.
even like we try to, like people at AI2 try to release a fully reproducible data set and 10% dies in the first 3 years or something. Like,
Right. And you might be having a lot of, I would say, additional overhead cost behind the scenes. So, I mean, thanks so much for doing that.
Hugging
But, I mean,
Face does it.
yeah, I mean, like when people does that, we're kind of raising our hands and saying hallelujah, right? Thank you.
Yeah.
But it's a difficult job, right? Because there might be legal battles behind the scene. There might be a lot of, I would say, data cleansing. And the worst come to worst is really just more like, so I sometimes use this metaphor, like, what I'm saying, buy Coca-Cola stock. And, Warren Buffett is saying buy Coca-Cola stock. It's literally the same word, but they mean something intrinsically different. I can't really, get my buy Coca-Cola.
That's an AI problem more than
Right.
like that's a
Yeah. But I mean, like, that's also a legal problem, right? So it's like, like in Git, we can say this, your public static void main is before my public static void main. But in data, you can't really say that. So there's definitely some technical challenges associated with that. Last but not least, like the reward model associated with, like our contribution and the causality of our contribution to the model to the actual rewards. So for instance, if I'm writing a PR on GitHub, people see my PR and they merge my PR, great. I did my contribution. But
see.
our conversation today is really meaningful. It can be a very good, I would say, like data corpus for our reinforcement learning to some extent. But, when people do that, they will not tell you, Nathan, they will not tell me, they will not tell any of us, right? So
yeah, I'm lucky enough to be big enough and visible where I accept that like me being in it is now good because it reinforces that invisible. Just a technical note on language. You were saying reward model as in the thing that it rewards people for participating. Reward model is also like a technical thing, which I've done a lot of work on. So I was slightly confused. Yeah. But if there was anybody else that was confused, that's been clarified.
Thanks for clarifying. Yeah.
To kind of zoom out, I think that listening to you, it's like, wow, you're one of a few people that is totally up to date on the open source definition stuff in the world. And I'm sure there are people all over that are thinking about this. I think you've spent a lot of time in both cultures, and it's like, where do you feel like people in my seat versus your seat may see things differently with like what open source AI means, what AI means generally, or like anything in this space that you feel both in your job or your life with respect to AI?
Yeah, I mean, it's a lovely question. I think it might be too big of a question too. So I'll probably answer that through like two focuses. One is about open source ecosystem, like overall, like my feeling of being a engineer by training and a global citizen, how I perceive open source ecosystem in general. And the second part is about the Chinese AI ecosystem. Yeah, so we can tailor on that. So I would say first thing first about open source ecosystem in the West and in the East. The first thing first, there are definitely more similarities than differences. I'm not sure if you read a book called The Alchemist. It's one of my favorite small book.
I haven't actually read it. I do own it, unfortunately.
Yeah. So, well, congratulations. You have a nice book, like on your waiting list. It's totally worth it. Another fun fact is like, I used to be working at Square, and the Square's core payment system is called Esperanto. When I was looking at the word, I was like, what does that mean? Like days after I learned that Esperanto is basically this terminology related to world language. So there was a time people are inventing this term called Esperanto in hoping to connect the human beings all together by speaking the same language. But clearly it didn't work. But now Python is probably the real Esperanto to my, best knowledge. So that's why I'm saying that there are definitely more similarities than differences, because in open source domain, people working together, like they write Python code, they write JavaScript, they speak English, they share their ideologies and, meanings about technology. It's all good.
I guess a spicier way to phrase this question is like, why are there so many more open research labs in China than the US? I think like both the US arguably has like a bigger in market cap, but fewer in people tech ecosystem. And it's like, why is it's like, I listed what I thought was like 20 reasonable, like there's like twice as many reasonable contributors in the Chinese ecosystem than in the US.
Right.
Like, do you think there's a reason for this, or is it just kind of how the dice fell?
Well, I mean, like, I have my perceptions. Allow me to maybe use a disclaimer. So this is only my perception, not my company's. So it kind of feels like there definitely, there might be as many AI research labs in the States too. For instance, I mean, only through you, Nathan, I learned about AI too. And I mean, I used to be living in Belleville for years, but I didn't know such an institution exists. So this is how uninformed I was, and I would imagine that there will be very much similar people like myself who are, uninformed in that regard. Like, truth being told, we do see more open AI labs in China this year. I would say there are two reasons behind that. One is model effect. I would say that, people are kind of perceiving the success of DeepSeek as a role model. That's, I would say, like a general consensus. It's probably also a global consensus at this moment. People appreciate about, their engineering excellence and their willingness to share their findings. Because again, if you're just out of Lisbon, we would appreciate the ship who came back and tell us, hey, this is the wrong way. Go that direction. We'll probably appreciate that.
It would be good if more people did that.
Right. So it's not zero sum game. It's not zero sum game. So we cannot really speak on the others' behalf, but we clearly see, Alibaba with QN and, Ant Group with, Inclusion AI. We're doing the same thing. We know it's a long journey. It's odyssey. So when you're just outside of Lisbon, the best strategy to do is to be open and be helpful. And people appreciate, the individuals who actually help you in university rather than the individual who came to you after you became famous.
I think I approach AI with this sort of curiosity. I think I don't know how this would be a good test, is like there's a very, the colloquial term of the hour in the Bay Area in like tech circles in the US is like locked in. And if you apply this to what the AI companies think, it's like the AI companies in the US are really, really like at least acting as if they are locked in on a discovery in the near future that's going to be transformative. A lot of it is probably for fundraising, but it's like, I think that's like, I have a lot more to learn, and I will talk to more people like yourself to like pick up more of this from talking to Chinese researchers. But I think this might be a recurring theme of like a lot of the U.S. companies like have this marketing that is really just different than how you're describing it, and it'll be interesting to see if that keeps coming up. Because if you're so focused on like a 1 to 2 year thing, you're not gonna like sharing has a very different action to give. And then it's very different.
I mean, like, just things in perspective, I mean, like, truth being told, that by spending quite some time on both sides, I would say what we observe nowadays is reasonable, but definitely not ideal. So I would say first thing first, like the chip leader are actually having a different way of playing the game, which is reasonable. I would say that, like if you're the chip leader, there's no guarantee that, if you're going to be playing the same game. That being said, like we don't talk about such a hypothesis because you cannot prove or disapprove it. But that's basically the first thing. And the second thing is we're definitely seeing, like there are an intrinsic, I would say, systematic risk with the direction we're going, right? So you hear people talking about, the transformer, architecture is, are we actually raising, even with all the famous, names, they begin claiming that, hey, the pre-training might be dead, right? We hear terms like that, or, reinforcement learning is the way to go. But, in the latest interview with Andrew Kapasi, right? So he has this kind of, he shares this in a very humble and noble way, right? Saying that, hey, this might be the right, this might be a good way to go, but let's not, like mystifying this, right? It might not be the, the golden desire, or it might not be the silver bullet. It's a good methodology. Let's go down that direction and explore, rinse and repeat, in hoping that we'll be able to find it. So if we're at this stage of the game, I would say I would definitely choose a game to be more, I would say, open-minded. That's one thing. And then like from a strategic perspective, be less about zero sum and more about, where so in the game series, right? There are all these kind of different games. One very typical mistake people make is they will treat a stag and hare game as a prisoner dilemma game. Those games looks very similar in their own natural equilibrium, but they're different. So I guess we do see certain companies are playing more like, hey, you win, we lose. Can't comment on that, because there are a lot of reasons behind it. But the way we're kind of looking at is, there are definitely more rooms. Even as like Columbus was the first one finding the American continent. But then we begin to know that there's this kind of North America and South America.
There was a lot of settlers other than just Columbus.
There are a lot of settlers.
To finish your metaphor.
Right. So, you don't want to be the first pirate on Atlantic Ocean to kind of begin shooting down the other ships before you even reach and disembark. So that's basically like my way of seeing it. Last but not least, I guess, I think at this moment, there's also another intrinsic risk associated with the whole business model. We hear a lot of those discussions regarding to how NVIDIA is actually making a lot of money by just selling the hardware. I also saw a line yesterday, which I really like, is like, hey, do people still remember Cisco in 2000? I was like, that's a very powerful line. That is a very powerful.
I think a lot about how like Claude Code is very different than the likes of GitHub Copilot. And it's like the different products that you can make with a given model has very, very big delta in terms of what the user gets out of it. So mostly the floor is yours to comment on anything fun in the product, which is probably a lot of your actual day job. This is not my day job, and I get the sense that people that care about AI have to do a lot of work like this of like creating a vision. And I'm guessing product might be closer to what you spend your time on.
Yeah. Again, thanks so much, Nathan. I really enjoyed the conversation today. So the Model as product team is very new. It's brandly new. It's only 1 month old. And as far as I know, we're like the first company building such a team in China, if I'm not mistaken. But I have a hunch feeling that's how people in OpenAI are working nowadays, right? So people are kind of working in small squad teams with 7 to 8 people. It's a combination of algorithmic engineer, system engineer, UX engineer, product developers, evaluators, and so on, etc. So we're all looking
Did you launch this before or after Sora? Because Sora is a complete vindication of this, which is like the genius of Sora is adding your friends to the videos versus just having a good video model. So you may not have realized it, but I think you have a great example of reinforcing this hypothesis. And I think more of them will come because I don't know, I'm like soapboxing, but I think 2026 will be like, there will be more things that we can't predict, like Claude Code and Sora every year that start to work. So I think it's a good approach.
Yeah, that's precisely how we work, right? Because working in open source for years, I guess one thing I learned is like, if you just begin selling, there's very, one of my favorite speakers is Simon Sinek, and he has a very popular YouTube video talking about leadership. So in there, one of his lines is like, leadership is about volunteering. I really love that line. So it's so basically, I'm pretty much volunteering my time and my predictions of trying to build such a team. So what our team does is like, because we are the Ant Ling team, right? So we care a lot about the model itself. That said, there are a lot of models out there. So in order for you to promote a model nowadays, it's intrinsically difficult because people will say, oh, okay, here's another model. Oh, it's an open model from China. Oh, there's so many open models from China. We speak, oh, great, I remember that, but what's next, right? So how can we use it? So so we were kind of looking at just like how we discuss about MySQL is if MySQL is a platform or an infra or product. I would say that we really want to think model as product now, because you have all these models, but you also the good news is like you also have the infrastructure which allow you to switch models very easily, like open routers and all this, model service providers, they actually allow you to do that very easily with very low overhead. You can use one model for part of your scenario and another model for the other part, which is good. It essentially means that if you have a good enough model, so I mean, thanks so much to our engineers who are actually building such a model for us to use and pretty much work upon. Without such a model, it's impossible to do anything. So now with such a model, it almost feels like you have a very smart individual with IQ equals to 120, but he's not very well trained with anything. So what we're trying to do is we're trying to really find, doing the interview with the model, right? So say, hey, what are you good at? But do we really know what the models are good at? Honestly, at this moment, it kind of feels like the evaluations are not really there. There's a long way for, benchmark evaluation. We don't have enough time for that. But I kind of believe that, eval-driven heuristic is probably going to be very interesting in 2026.
Yeah.
We're trying to essentially use a eval-driven way of finding what the models are good at. It can be very specific. It can be very niche for like creative writing, for example, in drama storyline. It's very specific, but you can build a very good product on that. We're trying to find all of those, but at this moment we need evaluation data set. We need all of this in order for us to be able to find it. And on the other hand, is we need to find the user value, because even as of in 2025, you begin seeing a lot of this new product coming out, but only a few things settled. So it almost kind of reminds me at the very early stage. I don't know, Nathan, if you remember the product called Foursquare from the very early days.
I don't think I was a man of the internet at the time, but I've heard of it as being a canonical reference many times. It comes up in a lot of the readings that I do.
Yeah. So the TLDR for that is the Foursquare is basically one of the earlier application. When you have an iPhone, all it does, it gives you a location of your current phone, and you're able to do a check-in action in there. So for instance, if you go to a restaurant, you can do check in. I'm at this restaurant. So what it does is actually it's a demo of the location API of iPhone, and all it does is data labeling and a demonstration of how you can use your location API to be useful. But without Foursquare, you will not really have Uber or DoorDash and all of those. So Foursquare was pretty much the demo which lead to all of these new products. And another way of putting that is you don't have to be a taxi driver to build Uber. So that's basically how our team is. We have a very small team. We have a very small team with engineers, product managers, and operational folks. So what we're trying to do is we're trying to essentially build Foursquare by really focusing on what the model is good at and what are the core capabilities, right? So I think there are definitely some of this kind of demoable core capabilities, which kind of begin surfacing. One of them is unlimited memory. Unlimited memory is basically this new capability, which only AI and Gen AI can fully utilize. Do we? So for instance, you have this kind of new products like the Cloud Note, which you can put behind your phone, right?
Yeah.
You can put a note there. I think there's a company called Unlimited .ai, if I'm not mistaken, which is basically the necklace you can put, and people kind of building watches, rings, glasses, and all of this in hoping to gather the data and trying to pretty much put the new all this kind of new context into the model. I kind of condense those into two core capability. One is unlimited memory. It memorizes everything. But in order for us to do that, you can't really save all the data, right? The data is huge. You have to compress it, being able to find a nice way of compressing them, and very nice way of retrieving them. So data compression, data retrieval, cold hot storages for all of this data, they're all new challenges. But the capability is real. So with unlimited memory, it will really enable this contextual engineering work, which you can use a model for, but it's not there yet. So it can be a Foursquare moment for the LLM. And the second one is, I would say, the proximity awareness. So for instance, we're speaking in the room, there are a lot of these kind of new applications which are recording our meeting. What they're really recording is a meeting, yes, but what they're also recording is who is sharing the meeting with you. So theoretically speaking, you have sufficient amount of data, you can begin building the new LinkedIn in the Gen AI era, right? So it's all possible, but we're not there yet. So
yeah, I think there's a lot of pushback on privacy in the US to these things, but I think demonstrating the capability is obviously a huge merit of like, if we can figure out the privacy concerns, you have X on the table of new potential things. And I think it's good. I encourage a lot of people to, that's the right approach to things, which is like, as the models get better, what potentially can work. I'm not a new person to saying this. A lot of people have.
Yeah, maybe just like 2 final words. One is like, I guess now is probably the best time to be more, I would say, first principle. Like, people say that a lot, but, I actually have a 3-year and 10-month-old boy at home. I guess one thing which really motivates me, what kept me being optimistic is, my boy, because his growth is very well aligned with, the timeline of the model. I'm seeing a lot of similarities in terms of how the revelations of human beings are kind of aligned with how the models are being trained, both like pre-trained and post-trained. Yeah, I'm seeing there's a long way to go. We don't really have any understanding about, I would say, human intellectual intelligence, about where that's coming from. So it's a long journey, and it's good to really kind of think more, fundamentally at the first principle. And the second line is, I would say, inclusion AI and Ant Ling team. We're being very serious about this. We don't think this is zero sum game, and we don't think this is red ocean. So I would say we're very open. We'll stay open for as long as we can. And we're doing all these kind of explorative approaches. And I'll probably make a call to action as someone who has been benefiting a lot from globalization, including education, and being able to work with smart people like you, Nathan. I hope the world will stay that way, at least as far as technology and open source is concerning. Yeah. So by all means, work with us, and Inclusion AI will be here. We'll keep exploring, and appreciate everything you've been doing for us. Thank you so much, Nathan. I will really, really enjoy this conversation today.
Yeah, I look forward to seeing your new models. I've been so busy. I have one of these DGX Spark computers on my desk, and I haven't downloaded any real big model to it. And it's like, I have to try downloading some like 100 billion parameter models to see how it works. So maybe one of them will be your model. I have a list to try. But thanks for having me. I'm going to click the stop button and then just leave it open for a second and we can wrap up.